thinking since this is Mountain Time, looks like it's 10 o'clock, Colorado or those environs. So again, hopefully I won't step on myself too much and say afternoon or morning, but 10 o'clock, 12 o'clock, it's kind of whatever. So my name is Scott Lewis, and I'm an instructional technology coach for Frederick County Public Schools in Winchester, Virginia. Winchester is in the northwest corner of Virginia, and I serve a high school as my primary role. And right now we are getting set to come back 4 days a week on Monday. We've been hybrid for the entire school year, so it's been a combination of students in class along with virtual students, Google Meeting throughout. So I rarely use Zoom, so excuse the bells you're going to hear, and also excuse me for some of the mistakes I may make on Zoom, since we don't use it that much here, just Google Meets. So I'm going to share my screen, and as I share my screen, I'm going to actually stop my video because I'm going to be working on dual monitors, and so it'll look kind of weird if I'm staring at something else and have my camera off to the side. So one thing, I can move this around right here. And so this is engaging students in critical thinking with Codeblocks. So I've spent a lot of time with students at the high school level and middle and elementary school, kind of exploring ways to create. And for me, this is a big deal because, it dawned on me thinking about my own education, but also my kids' education. And I'm blessed to have the opportunity to have them both in the school that I serve. And so it's kind of one of those things where, I ask them, when was the last time you truly enjoyed learning and coming to school? And they both said elementary school. And while that didn't surprise me, it really distressed me. And I realized that part of the reason why they really enjoyed going to school in elementary school was they were able to create. They were able to build on the knowledge that they were gaining in classes, take that knowledge, and then do something with that. And we've kind of gotten away with that throughout the last couple of years. We're a one-to-one district, so we have a lot of Chromebooks. Every single one of our students, kindergarten through 12th grade, has access to a Chromebook. But what I found was that as soon as my kids went into middle school, their teachers went into Chromebook babysitting mode. And so there are a lot of playlists, there are a lot of students would come in and there would be a Google slide deck for them to get on, some videos to watch, and then a hyperdoc for them to complete. So it was a lot of stationary, sedentary learning that was going on, and there was no creation. And so one of my goals, one of my missions here at my school, but also district-wide, is to get back to the point where students are creating. So my teachers here at Millbrook and students here, we spend a lot of time in class creating 3D models using Tinkercad. We create videos, we create virtual reality experiences. So they can build on that content and really look into those 21st century skills that become incredibly important for life after school. So things like critical thinking, innovation, creativity, communication, collaboration. So any way that we can get students to be able to build on those skills, infuse content, but get back to the point where learning is fun. So how does that mesh with all of this? Well, the simple answer is that, again, it comes down to engagement. And I'm not talking about engagement in the sense where, you walk into a classroom and students are, engaged in typing out a document in, Google Docs or something, but truly engaged in thinking, in creating, in connecting with the content. And that's something that we as educators really strive for, is that connection. But it's not really the connection that we provide for the students. It's that connection that students create to the content themselves. So what I've started working on with teachers in the building this year is looking at how we can infuse computational thinking into the curriculum. So looking at that, again, this is me. I'm going to have a version of the slide at the end. You can contact me, email Lewis S, or on Twitter at ScottLewisITC. And again, I'll put that up at the end as well. Our learning targets today, we're going to look at definitions of critical thinking. We're going to look at the definition of computational thinking. But really what I want you guys to do is to be able to use Tinkercad, use Codeblocks to be able to create your own computer program that designs something. So this will be a kind of, watch, learn, and then do kind of thing. So at any time, definitely, if you can split your screen, if you have two screens working, put this up on one screen, pull up a second tab, or, if you can split your tabs and have this one going and another one going at the same time, awesome. Because I want us to get to creating. So again, my ground rules for anytime I'm presenting are very simple. If at any time you have a question, don't hesitate to put it into the chat, but also don't hesitate to unmute and ask that question. I find that these become more fun, especially virtually if we're doing something and it's more participative. So again, definitely questions, concerns, whatever, just unmute or hit up the chat. So this second portion, critical thinking, this is one of those, portrait of a graduate life skills that we want all of our students to become good at. So it's, in looking at, definitions for it, it's a process. And it's a process of questioning and reflecting on knowledge and information that's presented. So not just thinking about it or not just reflecting about it, but questioning, reflecting, and really thinking of, how we can use that knowledge that's being presented or that we're researching and apply it in different ways. So that's where the creation part comes into it. Now, what we're going to talk about next is that computational thinking. And I don't want you to think that this is all about math. This is all about science. My background is as a history teacher. I use this in computational thinking and coding in English classes, both co-taught, self-contained, and honors and AP level. I use it in history classes, art classes, and definitely science and math classes. So computational thinking is, thinking that expresses solutions as a series of logical steps. So it becomes that, critical thinking to the next level. So you're looking at those logical steps that it takes to solve a problem, or to create a process, or to create a document, or a 3D model. So it's looking at that mathematical step-by-step process, which is computational thinking. So this is the reason why coding and creating 3D models in class isn't just relegated to the math classroom, because it really has things that you can use in any class. So first thing we're going to look at is, I'm going to show you Scratch. I know the beginning of this, it says Codeblocks and Tinkercad. Codeblocks is based upon the Scratch language. So I want to show it to you first because this is the basis of the programming language in CoSpaces, which is they call block coding, in Tinkercad, which they call Codeblocks. It was developed at MIT, and it's a really simple and easy way to get kids coding, because you don't really need to know the coding language. You just need to know how to use, and think about commands. So we're going to look at that first, and then we're going to use Tinkercad. And so usually Tinkercad, when I explain it to students and teachers, is it's 3D modeling software. It's not a watered down version of CAD, but it's a nice entry level version of CAD that anybody can use. And usually when I design something, I'm using Tinkercad. I don't go into CAD software or anything more complicated than Tinkercad. Okay, so we're going to go to Scratch. So if you'll be so kind, if you're going to operate and follow along with me, we're going to create a simple code to be able to draw a circle. So all you need to know is this website right here, www.scratch.mit.edu. And I will copy that and I will put that into the chat. Oh, awesome. Thank you.
No worries. I can do this for you, Scott.
Oh, you're awesome. So definitely enter that in. And what you'll end up getting is, I'll start from the beginning. It'll ask you to log in. And it'll take you to a screen like this. And then all you have to do is sign in. And once you're there, all you have to do is hit create. And it'll bring you over right here, and it's going to take a second. So this is the basic landing page. And again, the reason why I want to show you this really quickly is this can do some things that Codeblocks and Tinkercad can't do. And I'm going to replicate a little bit of the drawing a circle in Tinkercad, but it's much easier to see on here. So a couple things we're going to do. This is your main character. It's called a sprite. And I'm going to get rid of this. And I'm going to trade this sprite out for a ball, just because, I kind of find this to be a little distracting. So to do that, I'm going to go down to this pane right here. If you follow my cursor down, there is a blue circle down here that has a cat face in it. So just click on that. And it brings up every single sprite that you can get. So I'm going to go simple, and I'm going to get this ball. So I'm going to click right there. And I have a ball here. Okay. Also going to get rid of that sprite. So all I have left is this ball right here. Now, I can either show it or hide it. Okay, so that's up to you. I'm going to keep it right up there. So what Scratch and what Codeblocks end up becoming is a simple drag and drop operation. Okay, and this is where the computational thinking comes in. So the end result of this is I want to draw a circle. Okay, so what are the steps that it's going to take to draw a circle? So the simple question, first of all, is how many degrees are in a circle? All right, thank you, Robin. 360. Yeah, so we're going to do some simple math here. So 360. So the first thing that we need to do is we're going to click on these events. And we're going to bring this over when clicked. So this is something that you have to do in Scratch. You don't have to do in Codeblocks. It already has that available. Okay, so when clicked, so that means that when we click this green flag, our program is going to start. The next thing we need to do is I want to add something to Scratch. Okay, and this is where Scratch becomes a little bit better than Codeblocks because I have the ability to draw on this, and I don't really have the ability to draw in Codeblocks. So I'm going to click down this lower left-hand corner. It looks like a cartoon version of all of these. So I'm going to click there because I'm going to add this pen to it. So I'm going to click this pen, and this allows me to draw. So I'm going to create a program that's going to draw a circle. Okay. So I have when clicked. So I'm going to drag over erase all. Okay. So to do that, all you have to do, left click and hold and drag this over. Okay. So the first thing it's going to do is it's going to erase everything on the screen. Second thing I want to do is I want to bring it and make sure that I start drawing. So I'm going to drag this pen down program right there. Okay. So right now, if I were to click this flag, I could do that. It's going to erase everything and it's going to put the pen down. So again, what this is also good for is having students understand that it's okay to make mistakes and it's okay to revise things because this is a step-by-step trial and error process. Unless you know right off the bat how to do this stuff, it really becomes that trial and error. Well, how can I make it do this? How can I make it do that? Because it's truly a computer program. So it's only as smart as the programmer. So it will only do what the programmer tells it to do. Okay. And so this is just scratching the I guess the bottom level of what we can do with this. And why this becomes really fun because you can design a computer program to explain the setting of the story or to create a historical scene, anything like that. So basically the only limitations are creativity and ability and imagination. So we have the beginnings of our computer program right here. The next thing I want to do is I want to create something that's called a loop. Okay. So basically I want a couple steps in here and I want them repeated over and over. So I'm going to drag, so left click and drag this repeat over. And this is where my computer program is going to be. Okay. So Robin said earlier that a circle has 360 degrees. Okay. So the number we're going to put in here is 360. Okay. Because we want a dot to appear 360 times and draw a circle. Okay. So we have this. The next thing that we need to do is go up and click on motion because now we want that dot, that pen down right here to start moving. And this is where we really start drawing the circle over here. So we're going to look at motion. And the first one that we get is we want it to move one step. Okay. So let's see if it does that. Okay, so we have a really interesting thing right now. What we've done is we've created a computer program that draws a straight line. So what we need to do and what our task is to draw a circle. So this is where that, reflection and, revision comes in. Well, how do we get to draw that circle? Well, we need to turn certain amount of degrees, okay? So we have it going one step, we're gonna make it turn 1 degree. And we're gonna have it do that 360 times. So press the green button. And now you see that it's drawing a circle. So this is a really good opportunity to, if you're teaching, math, geometry, anything like that to, students that, at any age level, this is a really good way to have them truly visualize these shapes because, it makes that, that conversation of, well, how many degrees are in, this object come to life because now you're creating a program to be able to do that. Okay, so I'm going to give everybody a second to do this simple computer program on their screen. If you're following along and doing that. If not, just let me know and I can move on to the next thing. So as you're doing this, I want you to think about how we can make this move faster. Okay, so it drew a circle, but it drew it relatively slowly. So how can we cut that time into half? I'll give everyone a hint. There are 2 things that we have to change, and that's it. We don't have to move any more blocks. We just have to modify 2 variables in that program. So what's one of those variables that you guys think that we have to modify? All right, so I'll give you a hint. We're going to modify this repeat. So we're going to modify it to 180. Okay. So if we modify this to 180, that means that we need to modify the degrees as well. Okay, because we want these 2 to end up being 360. Okay, so I'm going to modify that to 2 degrees, and I'm going to press play. Okay, so a slightly smaller circle. Let's look at 2 steps right there. Let's see what that does. There we go. So we've got our same size circle. So what we just found out is that we need to move the same amount of steps as we move degrees. So if we want to make it even faster, repeat it 90, which makes this 4 degrees, which means we need to move that to 4 steps. And boom. So now we're creating the circle, but we're doing it faster and faster. So the same thing goes into this. How do you create a different shape? So if we look at a pentagon, or even, well, let's look at a triangle. So we've got 60 degrees. Let's see if that'll get us a triangle. Nope. All right, we're going to draw a hexagon, I guess, because I'm not figuring out how to draw a triangle. So we're repeating this 6 times. It's turning 60 degrees. And so we're making that triangle. Okay, so again, this is a really good way, make a pentagon while I'm talking, of showing students how you can design, just a simple program to draw these shapes. And once you get them to understand, that process of drawing a circle, then it just becomes, okay, so how can we take that to the next level? How would you create a pentagon or a dodecahedron, or how would you create a shape that has 14 sides, and things like that, just to be able to have them take it to the next level. Okay, so this is, again, Scratch, and this is the basis of what Tinkercad uses as a coding language. So I'm going to shift us over to Tinkercad. And what I'd like you guys to do is go to Tinkercad.com. I just stuck in the chat for you. And what it'll look like, and the landing page will look like this. Now, the great thing with this is this does give you the ability to create classes, so you can push out assignments, and it will also mesh well with Google Classroom. So I'm going to sign in real quick and sign in with the almighty Google. And Google will take you into your main landing page. And again, the main destination, the main reason that Tinkercad is here is to design 3D objects. I've been working with our travel and tourism class here at the high school to show them how to create a hotel room. And we worked with our interior design class to create and furnish a bedroom for them, and then we're printing them out. And in fact, I have my 3D printer going right now, finishing out some of the hotel rooms. So this is why you're seeing a toilet and that kind of thing on here. What I want you to go to is click on Codeblocks right here. What we're going to design using coding is a wheel. Okay, so I'll bring this up and kind of show it to you right here. Okay, so we're going to create this object right here using a computer program. Okay, before we do that, though, we're going to look at how to draw a circle on here. Okay, now looking over here, what I really love about Tinkercad is the fact that, again, it's drag and drop. It's a really great way of teaching algebra and geometry, spatial reasoning, things like that, just because you're looking at those shapes and you're looking at how to create stuff. Also great for art because you're looking at additive or subtractive sculpture and creation. But in this case, we're going to create a computer program. So we have shapes. We're going to modify those shapes. We're going to control them. We're going to create a variable. But again, the one thing that we don't have to do is there's nothing here that says when play is clicked. Mostly because as soon as we drag something over, this is going to interpret that when we click this play button, it's going to play that that program. So first thing I want to do is I want to create a variable. Okay, this is going to allow us to rotate something. Okay, so I'm going to go down to this math and I'm going to left click and drag this onto here. Okay, so once I get it up here, right now it says item, but I want to I want to rename this as the variable, and the variable is going to be rotation. So I'm just going to click right in here and I'm going to click rename. And I'm going to click on rotation. Okay, so now I have this variable and I'm going to set this to 1. Okay, so this becomes important because it basically creates data. Okay, we're going to use this data block to control an object. Okay, so we're going to take a shape and we are going to drag over this create new object. And we're going to rename this. So same process, rename this as circle. Okay, this is a step that you can or you don't have to do. I use this just because sometimes if you're creating an object that has multiple shapes or multiple things within it, this is good because once you create this, this will end up, if you go down to data, you can reuse this shape in something else. So we're going to go up here and resize up there, create a new object. So that object I'm going to create is, I want to drag over a sphere. Okay, so I'm going to push it right here. And then I want to modify it a little. Okay, I want its radius not to be 10 because if I put it up there, it's going to be a fairly big sphere. So I want to bring this down. I want the radius to be 1. And so that's what that looks like. Okay, so now I have this ball. Okay, and now I want to move this ball. And I want to move this ball 20 units to the right. Okay, so this is where some algebraic geometry comes in because this is the x-axis. So I want to move it 20 units to the right on the x-axis. Okay, so to do that, I'm going to click in here and move 20. So now it comes in and it moves it 20. Okay. Next, I want to put a repeat out there because now I want to start rotating this and moving this. Okay, so I see we're kind of running out of a little time, so I'm going to go back from this. I'm going to show you what this program ends up looking like as we go through this. Okay, so this is what the program looks like. So creates this new object and it repeats it 45 times. And we're going to add the object. It's going to move 20. It's going to rotate around the z-axis, which is this vertical line right here, not the north-south nor the east-west, but the vertical line right there by the rotation. So we have that variable right there from this pivot point right here, okay? Now looking at this, we're to do this and modify it. Let's say, take that 90, make that 4. Here's where that changes. Okay, so it becomes a little slower, but the circle becomes a little better, okay, because we have more of these objects coming around, okay? And you notice it's running through the program 90 times. Okay, so this is a good example of how you can start using Tinkercad Codeblocks as a different way of designing things. But what I really like about this, I'm going to go back here. What I like about this is that now you can create different objects. And excuse me while my computer acts up and becomes incredibly slow. There we go. Okay, so let's take this from square one. Let's say we want to create a snowman. So again, the object here becomes, how do we take an everyday object and use computational thinking to put it into steps that we can use, okay? So we have an idea of what a snowman looks like. So we're going to name this bottom snowball, okay? So we're going to create a new object, and it's going to be a sphere. And if we play that, the sphere comes up. Now, what we need to know about Codeblocks is that it is going to put it right at the origin, okay? So it's going to put it right at 0, 0, 0, okay? Which means half of your object is going to be below the printing table or below this horizon right here, okay? Which is okay if we're just designing something in 3D land, but if we're going to print this out, we need, the next part of this is we need to move it up a certain amount of space, okay? So if we're looking at this, the radius is 10, okay? So the radius is 10, that means the diameter is going to be 20. So what we can do is we can modify it. We can move it up the z-axis 10. So when we do that, now the first thing it does is it puts this up on the origin right here, or actually it moves it up from the origin 10 spaces. Okay, so we can also go in here, change color. The snowmen are blue. And that changes it to look like that. Okay, now kind of figured out, oh, I want to make this bottom ball a little bigger. Okay, so we're going to make it radius 15. Okay, so we change that to 15, but looking at that, okay, now we have to change the move right there because we want to bring it up that same amount. Okay, so this is where that step-by-step, revision and going back and forth to this ends up being really helpful. And again, it's a great way to teach kids how to revise, and that, it's, you're constantly going back and forth with it. Okay, so we have that creative first new object right there. Okay, so now we have that bottom ball. Okay, so that becomes really important because we can go up here and we can create a new object. And we can create a new object. We're going to add a copy of this ball because, again, why recreate the wheel? We can put that right into there. Okay, we want to rename this as the middle snowball. And we want to move it, because it'll be right here. We want to move this up. Let's go 15. So we want to move it up an additional 15. Let's see what we get. We need to move that up even more. And in fact, let's scale it down a little. Let's go, yeah. We'll use scale. And we're going to make that 3/4 of that other ball. Let's see what that looks like. There we go. Now we still need to move it up. So let's see what 20 does. Okay, we're getting there. Want to maybe try 25. Yeah, there we go. Okay, so now we have the beginnings of what this is going to look like. Okay, so this is why, renaming our objects becomes important, because now we can reuse some of these things, and all we have to do is move them and scale them. Okay, we can even change the color of this. Okay, so again, what I like about this is it's making creation even more interesting, because now it's not just, okay, we're going to design a snowman and you're going to bring these shapes over and you're going to put these shapes on and understand that. Now it becomes, okay, you're designing this snowman, but you have to write a computer program to be able to do that. Okay, so you're looking at those computational steps to be able to do that simple plan. So it looks like we're about 5 minutes out, I guess. So are there any questions that you guys have? Okay, I'm gonna go back to my main slideshow. And again, barring any questions, feel free at any time, reach out, email. You can message me on tweet. Do you move on to non-block program at some point, or stick with? To be honest with you, Mark, at some point I would love to learn how to do coding, and I guess get to more complex coding. My problem is that right now I'm limited just to my own knowledge to like the block coding. But I would love to at some point, get into Java, get into Python, that kind of things. So subject areas, I've used this with our coding club. I've used it with math. I've used it with English. with 10th grade, we've used it to recreate a setting and scenes from a book. And the block coding came into CoSpaces, which is another kind of 3D modeling program that you create like VR and AR things into, but you can control the characters and things in it using block coding. I just planned a lesson with an English teacher today to use this to do some stuff with Fahrenheit 451. So what I love about it, it's very approachable, very easy to be able to use in any content area. You know, me as a tech coach, I'm lucky because my teachers allow me to come into their classrooms and, you know, experiment with things like this with them. They know that they can come to me with any, you know, harebrained idea and we'll make it happen. And this is kind of where this came about, is because, you know, they asked for a different way to be able to, you know, design something. You know, and some students wanted to take it further. So it's really, again, you know, I guess, you know, you're limited by your imagination and how you can, you know, have it fit your content area. And again, don't just limit yourself or, you know, your students to simple math. You know, use this for anything. Okay, so at this point, I'm going to stop sharing my screen and pull up my video again. And I'm going to wish you all a happy rest of your morning and rest of the conference. And I hope you guys learned some great things today.
Thank you, Scott. And just to remind everyone, we do have a hard stop at 10:50, and I put the survey link in the chat, so make sure and grab it before then. That's when this session will close out.
All right. Well, thank you very much again, and I appreciate you guys tuning in. I appreciate your questions.
Thanks for sharing.
Hold on, I'm stopping.